AP Cram, Calculus AB, Free Response, Exam Review, Question 8, Velocity and the First Derivative. All right, so Johanna jogs along a straight path for t is either greater than or equivalent to 0 minutes, because it tells us minutes right here, or t is less than or equivalent to 40 minutes. Johanna's velocity is given by a differentiable function v. Okay, so it's a function that can be differentiated. Selected values of v or t, that's velocity with respect to time, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. So take a moment to look at the values in this table. All right. Use the data in the table to estimate the value of v prime of 16. So basically, what is the derivative at a value of 16 minutes that occurs somewhere between here? Okay. I'll give you a moment to think about your strategy. All right, so solving this problem is really basic, but it does take a bit of thinking. It might not be so obvious to most of you, but for many of you, it might be obvious. This is the part where I repeat again that calculus is a thinking man's game. It's not necessarily straightforward mathematics. The mathematics portion of it is only half the battle. So, okay, we're concerned with v prime of t, okay? So 16 minutes occurs between 12 minutes and 20 minutes. This is the information that we're given. And if you consider 16 being like here, like, somewhere here, it's evenly spaced, 4 spaces to the right from 12 and 4 spaces to the left of 20 minutes, okay? So therefore, we can use the difference quotient or the slope between 20 and 12 minutes to figure out or approximate an approximate value of the derivative at 16. Okay, and the derivative of the velocity at 16 tells us how fast the velocity is changing at that particular moment in time. All right, so v prime of 16 is going to be approximately 240 meters per minute, because this is the value at 20 minutes, the value of the velocity that is, minus 200 meters per minute. 200 meters per minute corresponds to the value of the velocity at 12 minutes, over 20 minutes minus 12 minutes. This is our difference interval. So you're going to get 40 meters per minute in the numerator, and you're going to get 8 minutes in the denominator, giving us a value of 5 meters per minute squared. And some of you might be thrown off by the squared corresponding to the minutes dimension. Well, if you have meters per minute in the numerator and you divide by minutes, it's the same thing as multiplying by the inverse of a minute. I'll just illustrate. Okay, I'm illustrating the dimensional analysis here. So in the numerator, you have meters per minute. I'm just going to do shorthand because there's a great time lag between what I'm saying and what I'm trying to write, divided by minutes. And division by a minute or is the same thing as multiplying by its inverse. So we have, again, meters per minute in the numerator Sorry if this confuses you. Times, I'm going to use the dot to symbolize multiplication. 1 over a minute. So if you multiply this out, this is going to give us this. And the m is shorthand for meters, okay?